morning, dear students. Welcome to today's session on pavement design and highway construction. We are discussing on the module number 3, that is the construction of pavement. We are talking on the flexible pavement construction, and today we will learn a most important topic, that is for construction of any pavement, that is rigid pavement or else flexible pavement. The topic name is the stabilization. Now the first question arises, that is why stabilization and what is stabilization, why we are using the soil stabilization. So we can say the soil stabilization is the process of improving the shear strength parameters of soil, thus it increasing its bearing capacity in the road construction. Also we can say soil stabilization or the stabilization is the process of making any material or any things more secure and more stable. Okay. Stabilization required when soil available for construction is not suitable to carry the structural load. At that moment, generally, soil exhibit undesirable engineering properties unless they are treated to enhance their physical property. And to enhance this physical property, we use the stabilization. Stabilization can increase the shear strength of the soil, and it also controls its shrink swell properties, thereby improving the load bearing capacity of subgrade to support the pavement and its foundation. Soil stabilization is used to reduce permeability and compressibility of the soil mass, and also to increase the shear strength. Now, mixing additives that positively affecting the strength, also to improve the physical and desirable properties, and also to maintain the soil moisture content in the soil mass, that can be achieved by the stabilization process. So these are the advantages that gives the stabilization, that can be achieved by the stabilization. Now second thing is how you can perform the stabilization. Are we adding any other materials for the stabilization? Yes, we have two methods. The first is lime stabilization and the second is cement stabilization. Now in the lime stabilization, generally as a primary material we are using lime. Sometimes we use or we add the fly ash in the lime stabilization, while in the cement stabilization we use cement as a primary material. So let's talk about the lime stabilization first. In the lime stabilization we are adding 2 to 10% of the lime in the particular soil mass. The lime stabilization is suitable only for clayey soil. It decreases the swelling potential and swelling pressure in the clayey soil, and that clayey soil, as an example we can say the black cotton soil. Now adding lime to the soil mass that produce maximum dry density under a higher optimum moisture content than the untreated soil. Now lime is produce a decrement in plasticity index of the soil mass. The improvement in the strength of the soil mass is partially due to decrease in the plastic property of clay and partly to the pozzolanic reaction of the lime with the soil or the soil material. Now lime is also used with the fly ash. As we talked earlier, sometimes we use fly ash or we add fly ash in the lime material. Now when you are adding the fly ash in the lime, it changes the content of these two material. The fly ash content may vary from 10 to 20% and the percent of lime may lies between 3 to 6%. So this is all about the introduction of the lime stabilization. Let's move on the construction procedure of the lime stabilization. Now, when you are starting the construction of lime stabilization, first process that you have to follow is you have to prepare a subgrade. The first step, that is preparation of the subgrade. After preparing the subgrade, the soil that has to be stabilized is excavated by iron borrow pits and then pulverized. After this step, the part of the lime that we have decided to apply, that is about to 3 to 7% or 3 to 6%, and then the part of fly ash that is of 10 to 20% are mixed as a powder. So this two material, that is the lime and the fly ash, those two materials has to be mixed in the dry powder form. Okay, after this, that mixture is to be allowed to age for 24 hours, that is a day. Okay, now precondition of the soil makes the pulverization process easier, and after keeping this material for the age, then after you have to remix this material again. Initially we have added 3 to 7% of lime with the fly ash, and the remaining amount of the lime, the rest of the lime and the fly ash is to be added, and if necessary the water is to be added in that mixture. Now your mix is completely ready to apply. So the next step to be followed, that is the mix should be spreaded on the surface, and after spreading the mix you have to compact that mix so that compacted to the desired grade. After compacting the surface, the soil lime fly ash is cured by preventing it drying. After making it dry, or after keeping it dry for the sufficient days, then after your surface is perfectly ready. After that you have to make the field checks. That field tests are to be conducted to check first the moisture content during the compaction and dry density after the compaction. After conducting that test and the result, you may allow the road or you may allow the surface for the traffic. So this is all about the lime stabilization. Now next move to the cement stabilization. Now first initial level, let's discuss about the cement stabilization. In the cement stabilization, about 5 to 14% of cement is to be added to the soil and sprinkled with the water. As the cement hydrates, the mixture become hard, durable and tough. Now the main use has been to build a stabilized base course under a concrete pavement for the highways and airfields. This can be asked in MCQ, that the cement stabilization can be used or can be particularly provided at highways and the airfields. Airfields, like if you want to construct a runway, so at that moment you can apply this cement stabilization. Now soil cement mixture are also used to provide the wave protection on earthen dams. This is apart from the highway engineering. So when you are constructing earthen dams, at that moment also you can apply this cement stabilization process. Now well graded soil containing the gravel, coarse and the fine sand that will require 5% of cement by weight, and if the material that is of plastic clays, that material will require 14% of cement by the weight. While in cement stabilization, better the pulverization process and degree of mixing is higher, that will give you the higher strength. Now presence of unpulverized dry lumps of soil, that will reduce the strength as well as it reduce the durability of the soil mass. There are various useful additives which improve the properties of the soil cement, and those additives are lime, that is for clay soil, sodium hydroxide, sodium carbonate, and also the calcium chloride. So this is also one of the MCQ that can be asked, that what are the additives that improve the properties of the soil cement. So there would be lime, there would be sodium hydroxide, there could be sodium carbonate, also there could be calcium chloride. Now this is all about the introduction of the cement stabilization. Now let's move to the construction method. So for the construction, at the initial stage, first of all you have to prepare a subgrade layer. Now in the cement stabilization, an even mix is a very crucial. So therefore care must be taken during the screening with no prior preparation. As apart from stones and gravel, there is a risk of also removing the lumps of clay and thereby modifying the properties of the soil. So to prevent the lumps reforming after disintegration, the soil should be kept dry. Now the soil to be used is collected from nearby borrow pits and then it is pulverized in mixing plant, and also then after it is placed on the subgrade layer. After placing that subgrade layer, you have to prepare a subbase course. Now after preparing the subbase course, now even with a well prepared soil, the cement must be mixed in as thoroughly as possible, otherwise, as it is generally used in low proportion, that is 5 to 14% of cement, it will not be evenly distributed. Mixing should be done in 2 stages: dry mixing and second is wet mixing. The cement will begin to act on contact with water, which is why the water should be added to the dry mix at the last moment before the compaction in order to keep the time before it is used to a minimum, and this time is generally known as or generally called as a retention time, as this greatly affect the quality of the blocks or quality of that layer. The moisture content of the mix will be slightly drier than the OMC for sandy soil and slightly whiter for soil containing too much clay. That OMC is nothing but the optimum moisture content. Now it is then sprayed and compacted to the desired grade and camber. The surface is then cured by preventing the moisture from escaping by covering with paper or by the moist soil as it convenient for that particular site. So this is how we perform cement stabilization. The next topic that we will discuss is bituminous surfaces. We have previously learned about the different layers of the pavement. The bottom layer is generally known as the subgrade. On the subgrade we are providing subbase. Above subbase we are providing the base course, and above the base course we are providing the surface course. And in this surface course generally we provide the binder content. That's why that particular surface is also known as the bituminous surfaces. And in this surface we are providing different coating. So let's discuss on the bituminous surfaces. Yes. Now this is the section of pavement wherein you can see here prime coat, tech coat and the seal coat. Yes. So these three coats we are providing as a bituminous layer, wherein tech coat and the seal coat are in the surface layer, and the prime coat we are generally providing at the initial layer of the binder course. That binder course is the fourth stage of the pavement, and on that binder course we are providing this surface course. This is generally known as the seal coat. Yes. Okay, so let's discuss on the prime coat. So this is a surface of a prime coat. So let's discuss something on the prime. Now when a bituminous surface has to be laid on an absorbent or on the porous surface such as water-bound macadam, then a bituminous prime coat has to be first laid as a prior to laying the superimposed layer. Now let's talk about some objectives of the prime coat, how it is beneficial. The first objective is to plug the capillary voids in the surfaces. The next objective of prime coat is to harden the surface by binding dust and loose particles to promote the adhesion between the surfaces and the superimposed layer. Now the prime coat consists of low viscosity liquid bituminous material like cutback, that cutback having grade that is MC, and SC that is medium curing and slow curing, which will enter the voids of the surface. Now let's discuss on the construction procedure, how we apply the prime coat. Now first is the surface to be primed should be swept clean and free from the dust, and it should be dry. Then the large potholes, the depressions should be repaired before the priming. If there is any uneven surface on the base course, that has to be repaired, and that has to make the smooth. So large potholes if there is, or if there is any depression, that has to be repaired before applying or before constructing the prime coat. Next, the bituminous primer is sprayed uniformly over the dry surface at the rate of 7.3 to 14.6 kilogram per 10 meter square area by using a mechanical sprayer. Now next is the primed surface should be allowed to cure for 24 hours, and then after the traffic should be allowed until it gets cured. So this is what the prime coat construction is saying, that you have to make the surface clean and dry. Then after, if there is any potholes, you have to repair that potholes, and then after you can spray that bituminous by mechanical sprayer. But this has some limitation of the rate, that is 7.3 to 14.6 kilogram per 10 meter square area. Okay, this is the rate of application, so that it can smoothly spread it on the surface. And after spraying, you have to keep it for 24 hours to get cured. So after applying the prime coat, the second is the tack coat. Now for the tack coat, when a bituminous surface that has to be laid on the existing blacktop or a cement concrete pavement, then the bonding is provided by a tack coat. The tack coat may also be provided on the water-bound surface or water-bound macadam surface which has already been treated by the prime coat. The tack coat is usually applied by spraying bituminous material of higher viscosity, like the hot bitumen at the rate of 4.9 to 9.8 kg per 10 meter square area. The tack serves the same function as the prime coat. Here I must say you have to remember the rate of application. This can be asked in short questions, or that can be asked in MCQs, that at what rate the bituminous material or bituminous liquid is to be applied for the prime coat and for the tack coat. So for the prime coat, the rate is 7.3 to 14.6 kilogram per 10 meters square area, and for the tack coat, that rate is 4.9 kilogram to 9.8 kilogram per 10 meter square area. The functions, the benefit, both are same of prime coat as well as the tack coat. Yes, so this is how we can apply the tack coat. There is no any difficult or any tedious procedure for this. There is a simple procedure. First you have to make that surface smooth, okay, or level we can say. Then after you can apply the bituminous surface at some of the rate, and then after you have to keep it for cure for few days. So this is the simple procedure of applying the tack coat and applying the prime coat. Okay, after prime coat and the tack coat, you have to prepare a seal coat. Yes, a seal coat that consists of a single coat of a very thin surface that is applied over the certain bituminous pavement, such as bituminous bond macadam, grouted macadam, or premixed carpet, which are not impervious. The main function of the seal coats are to seal the surface against the ingress of water, to develop the skid resistance texture, and to repair an existing road. So after applying the tack coat, if you have allowed the traffic to flow over it, after some times if that surface is get damaged, so to repair that damage or to repair that existing road, you can apply the seal coat. So this is the main function of applying the seal coat. Generally, there are two types of seal coats. The first is premixed seal coat and the second is the liquid seal coat. So let us discuss on premixed seal coat and the liquid seal coat. In the areas of low rainfall, a premixed seal coat is applied over the carpet. For this purpose, a medium coarse sand that passing 1.7 mm sieve, and if it retained on 1.18 mm sieve, that sand has to be used at the rate of 0.06 meter per 10 meter square area. This 0.06, why this 0.06? Because it is a sand, medium coarse sand. That's why this ratio is very low. That is 0.06 meter per 10 meter square area. The binder required for this purpose is the binder that is bituminous. So the binder required for this purpose is 6.8 kilogram per 10 meter square area. This layer is rolled by a light tandem roller to give a smooth finished surface. The road may be opened to traffic 24 hours after the providing seal coat or the surface dressing. So this is all about the premixed seal coat. Next is liquid seal coat. In the area of heavy rainfall, a liquid seal coat is applied over the carpet. In this, a hot bitumen is sprayed on the existing surface at the rate of 9.8 kilogram per 10 meter square area. On this bitumen, weight of 6 millimeter size is sprayed at the rate of 0.09 meter per 10 meter square area. And then after applying that material, the surface has to be rolled by a light tandem roller. So this is all about the liquid seal coat. I hope students you understand this topic very thoroughly. In this lecture we have learned stabilization, have two methods, lime stabilization and cement stabilization. After that we learned on for the bituminous surfaces. We have talked about three bituminous surfaces. First is prime coat, the second is stake coat, and after that the seal coat. Seal coat has two different seal coats. The first is premixed and liquid seal coat. Thank you students for your kind attention. We'll see you in the next lecture.